hope you all are fine and doing well. So here I am again with you all to discuss the summary of today's chemistry class. Today we started with the definition of the complex compounds. Complex compounds are the compounds which are formed when the metal or ions are bounded to the anions or to the neutral molecules. In modern terminology, these complex compounds are called as the coordination compounds. On the basis of nature, the molecular compounds are generally divided into two types, that is double salt and the coordination compound. So here I am sharing an image showing the differences between the double salt and the coordination compounds. Then next we discussed about the Warner's theory. Warner was a chemist who put forward the theory of bonding of the complex compounds or the coordinate compounds for the first time. The postulates include the central atom exhibit two types of valency, that is primary valency and the secondary valency. Primary valency are ionizable and corresponds to the oxidation number, whereas on the other hand the secondary valency are directional and corresponds to the coordination number. This theory was based on experimental evidence rather than theoretical. This theory successfully explained the bonding of the coordination compounds, but on the other hand, this theory was having drawbacks too. It does not explain why only certain elements are forming the complex compound. It does not explain why the bonds in coordination compounds have directional properties. It does not explain the color and the magnetic as well as optical properties. So, to overcome this, the VBT, that is valence bond theory, and the CFT, crystal field theory, came later. Then we discussed about the applications of Warner's theory. After this, we discussed about the ligands and the types of ligands. Ligands surrounds the central atom and forms the bond with it due to the lone pair. Ligands are generally of three types: monoligands, polyligands, and ambident ligands. Monoligands, these are the ligands which coordinate the central atom at one position. Polyligands, these are the polydentate or the polyligands. These are the ligands which coordinates the central atom at more than two positions. It can be bi, tri, hexa, etc. Then ambident ligands. These are the ligands which coordinates the central atom at more than one position, for example nitro O. Then at last sir told us about the definitions which he has also mentioned in last video. So I hope you all understood what I have discussed in this video. Thank you and have a great day ahead.
Good morning everyone, my name is Anushka Thakur from class 12. As we know that we have started chapter 9, coordination compound. So coordination compound is also known as complex compound. This is a type of additional compound. So here coordination compound definition is retain identity even in solution state. It retains its identity even when it is in solution state. For example, you can see here and Werner's theory. The main thing in this chapter, the first introduction, we have studied about the Werner's theory. This Werner's theory, the full name is Alfred Werner. He is a Swiss chemist. He had put forward the explanation of the theory of complex compound. This complex compound or coordination compound both are the same thing, with the theory which he has explained on the basis of complex compound. This theory made him so much famous in Swiss. So there are two types, primary and secondary. So the applications of Werner's theory are: first, on heating with HCl at 373 K. K stands for Kelvin. Cobalt amines doesn't evolve NH3. And the second is primary valence of COL3, whereas the secondary is 6. And the last is all compounds differ in their reactivity. So the postulates of coordination compound. The first one is the central metal atom or ion in a complex compound exhibits two types of valencies. As in previous I have told that there are two types, primary and secondary. So here also it exhibits complex compound into two types of valencies. First is primary and second is secondary. So the second is primary valencies are ionizable and correspond to the number of charges of the complex ion. So whenever the discovery is there, some of the postulates they are giving according to their theory, and the drawbacks are always there. So the drawbacks of Werner's theory or for complex compound, That would be first, it doesn't explain why only certain elements form complex compound or the coordination compound. The second is, it doesn't explain why the bonds in the complex compound have directional properties. And the third one and the last is, and it doesn't explain the color and the magnetic and optical properties of complexes. Thank you. I hope
Good
you all.
afternoon. So today I want to start my video with a positive mindset, which is a little progress each day add up to a big result, which means every day you will do little progress, one day it will result for a big result. So I will start my video. So today we have started with coordination compound. First of all, we have learned that what is coordination compound. It is those complex compounds which are special case of compounds in which the metal atoms or ions are bounded to a number of ions or neutral molecules. After then we have after we have learned about two category under this coordination compound, which is double solvent coordinate compound, which was based on nature, addition and molecule compound. We have learned about its differences. Then we have learned more about double salt and coordination compound. And after then we have learned about complex compounds that have complex ion. Those compounds are called complex compound. After then we have learned about Wiener's theory, which was given by Alfred Weierstrass. He was a chemist. He put forward this theory to explain the formation of complex compound. After then we have learned about his postulate, which tells that central metal will be surrounded by two valency, that is primary and secondary valency. Then we learned about primary valency. Primary valency is responsible for number of charges on metal. It is ionizable and it is responsible for oxidation number. Then we have learned about secondary valency. It is responsible for direction. It is responsible for shape and complex structure. Then we have learned about Wiener's theory. The postulates of Wiener's coordination theory were actually based on explanation evidence rather than theoretically. Then we have learned about its drawbacks. Then we have learned about Wiener's modern electric theory of valency. Then we have learned about its application. Then we have learned about some important terms, which is ligands. What is ligands? It is a molecule or in which are coordinate. It is the molecular ion which are coordinated to the metal atom or ion. Then we have learned about type of ligands. These are of three type: monoligands or unidental ligands, poly or multidental ligands, and amidental ligands. Then we have learned about mono and unidental ligands, which is one donor atom or one point of attachment and can coordinate with the metal ion at only one site in the complex. Then we have learned about poly or multi-donated ligands, as its name only suggests. Multi or poly means many. Two or more donor atom or point of attachment. Polydental ligands are further classified as tri, hexa, and etc. Then we have learned about coordination compound. The number of ligands compound bounded directly to the central metal ion is called complex coordination number. Then we have learned about geometry, the linear, then we have learned about its geometry. Then we have learned about complex ion, coordination entity, coordination shaper. Then we have learned about how we have to make the structure of it, which is very important. We can see over here. Then we have learned about homophilic, one kind of donor
graph attached to the metal ion or atoms. Then we have learned about charge number of complex ion. That's all. Thank you and have a nice day ahead.
Hello everyone, today I'm here with my topic, that is Werner's theory of coordination compound. So let's start with the beautiful quote that nothing is impossible. The word itself say I am possible. So today I will tell you about first of all about how we got the Werner's theory. Then secondly I will tell you its characteristics. So let's start. So as we are known that we are studying chapter number 9, that is coordination compounds. As already I have told you about the coordination compound, so today I will take the main topic, that is the Werner's theory of the coordination compound. In the 19th century, chemists were puzzled by the certain class of the reaction that seemed to be violate valence bond theory. For example, the valencies of the element in the cobalt chloride and in the ammonia seemed to be completely satisfied. However, the two substances react to form the stable compound with let me tell you the formula for this. That was COCl3.6NH3. This was the formula for that, and the compound is known as coordination compound. Alfred Werner, born on 1866 and died on 1919. In the year 1893, at the age of 26, proposed the theory known as the Werner's coordination theory to explain the bonding in these compounds. Now, let me tell you the main features of the theory. As we know that Werner's theory was there to explain the bonding in these compounds like COCl3.6NH3. Then, first of all, the first was in coordination compound, metal atoms exhibit two types of the valencies. These are primary and secondary valencies. The ligands attached to the primary valencies are ionizable and they represent the oxidation state of the metal. The ligands attached to the secondary valence are non-ionizable and these correspond to the coordination number. Every metal has fixed number of the secondary valencies because its coordination number is fixed. Then next was that a metal tends to satisfy both these valencies. The primary valencies are satisfied by the negative ions, and whereas the secondary valencies are satisfied by either negative ions or neutral molecules. Next is the primary valencies are generally indicated by the, let me tell you, the dotted lines, like this is dotted lines in equal ratio like this, and the secondary valencies are shown by the normal lines like this. Let us consider it is a normal line like this, by the normal line. And next is that the secondary valencies are always directed towards the fixed position in the space. This leads to definite geometry of the complex compound. On the other hand, the primary valencies are non-directional. For example, in the metal has 6 secondary valencies, and they have the 6 secondary valencies, and these are arranged octahedrally around the central metal atom or ion. If the metal has the 4 secondary valencies, these are arranged in either a tetrahedral or a square planar arrangement around the central metal atom or ion. And the secondary valencies are responsible for the stereochemistry of a complex compound. So I am finished with my topic for the Werner's theory of the coordination compound. So as I told earlier, the quote that nothing is impossible because the word itself say that I am possible. So thank you and have a nice day ahead. Non-ionizable, and these correspond to the coordination number. Every metal has fixed number of the secondary valencies because its coordination number is fixed. Then next was that a metal tends to satisfy both these valencies. The primary valencies are satisfied by the negative ions, by the negative ions, and whereas the secondary valencies are satisfied by either negative ions or neutral molecules. Next is the primary valencies are generally indicated by the, let me tell you, the dotted lines. Like this is dotted lines in equal ratio like this, and the secondary valencies are shown by the normal lines like this. Let us consider it is a normal line like this, by the normal line. And next is that the secondary valencies are always directed towards the fixed position in the space. This leads to definite geometry of the complex compound. On the other hand, the primary valencies are non-directional. For example, in the metal has 6 secondary valencies, and they have the 6 secondary valencies, and these are arranged octahedrally around the central metal atom or ion. If the metal has the 4 secondary valencies, these are arranged in either a tetrahedral or a square planar arrangement around the central metal atom or ion. And the secondary valencies are responsible for the stereochemistry of a complex compound. So I'm finished with my topic for the Werner's theory of the coordination compound. So as I told earlier, the quote that nothing is impossible because the word itself say that I am possible. So thank you and have a nice day ahead.